Hi everyone, we are team I Will Have Order and we are from Pei-Hwa Secondary School. I am Grace and these are my team members, Ingrid, Justin, Felicia and Brian. Today, we are here to share with you about our 𝑹𝒐𝒃𝒂𝒑𝒐𝒓𝒆 So, what are the 4 features of our robot? 1. We'll be sharing with you about the sensors we are using. 2. The use of our electromechanic design. 3. Type of interactions during the performance. And 4. What type of software solution we use.
Part 1. We will be sharing with you which sensors we use and what are the important parts. We used a LEGO 𝑹𝒐𝒃𝒂𝒑𝒐𝒓𝒆 color sensor, a LEGO 𝑹𝒐𝒃𝒂𝒑𝒐𝒓𝒆 Ultronic sensor, and a microbit Ultronic sensor. But what do these sensors do on our robots? The 𝑹𝒐𝒃𝒂𝒑𝒐𝒓𝒆 color sensor used to detect the intensity of all the light in 𝑹𝒐𝒃𝒂𝒑𝒐𝒓𝒆 environment to allow him to follow the path we made for him, and for telling 𝑹𝒐𝒃 where he needs to move next. For LEGO 𝑹𝒐𝒃𝒂𝒑𝒐𝒓𝒆 Ultronic sensor, it's for tracking the distance 𝑹𝒐𝒃 is from Eve, mainly to tell him when to give her the plant. For the LEGO 𝑹𝒃𝒃𝒂𝒑𝒐𝒓𝒆 color sensor, the purpose is used to detect the intensity of light in Eve's surroundings and for telling Eve where she needs to move next. For axiom sensors, LEGO 𝑹𝒃𝒃𝒂𝒑𝒐𝒓𝒆 color sensor is used to detect intensity of light in Axiom's environment. For LEGO 𝑹𝒃𝒃𝒂𝒑𝒐𝒓𝒆 Ultronic sensor is for tracking the distance Axiom is from the robots, mainly so it doesn't bump into the robots during the performance.
For part 2, we are going to talk about the specific designs and the reason behind each build. So let's get started. So there are a few reasons why we came up with designs. Firstly, we need the robot to have a low center of gravity due to the fact that we don't want it to fall over during the runs and competitions. Secondly, we use gears for a better turning ratio. Thirdly, speed is also one of our priority, thus we need to make sure it moves fast. Next, we decided to improvise and use tracks for more friction and it looks better so that it matches the one in the movie for 𝑹𝒐𝒃. Lastly, we use a special method in our coding which Brian will explain later, which therefore needs us to use 2 light sensors. Those 2 light sensors are being placed at the front of the robot. For each axiom, aka the spaceship, we design it in a way so it looks similar to the one seen in the movie. Other than that, the robot will also need to have a low center of gravity as it's taller than the rest of the robots. Thus, we have to extend its base so that it will not fall over.
Part 3. What are the interactions between the robots and us? What will each robot be interacting with? When the program starts, Axiom will move to the left to reveal 𝑹𝒐𝒃. 𝑹𝒐𝒃 will start looking for Eve. When 𝑹𝒐𝒃 finds Eve, he will open his compartment to reveal a plant. When Eve sees the plant, she will rejoice.
Hi everyone, my name is Brian and I will be continuing part 4. So, what are we going to do for part 4? Well, I'm going to show you my program and how I programmed it and how challenging it was to program. So, as you can see, for part 1, I'll be going through 𝑹𝒐𝒃, and for part 2 will be for Eve, and for part 3 will be for Axiom. So, this is the program for 𝑹𝒐𝒃. I know it might look lengthy, but I'll try my best to shorten it for you. So this is the shorten. This is what I call the essence of the program. So there are 3 different main commands for it. One will be a left tilt rotation, where the robot will follow the line for a certain rotation. For left tilt and right tilt black is when both right either left or right color sensor is being used to find the black, and you will stop once it sees black. Similarly for if, this is also quite lengthy, so I will shorten it for you. So this is the shortened one. This is for right and left till black. If is quite easy, as she just has a few functions to do. So this is 𝑹𝒐𝒃𝒂𝒑𝒐𝒓𝒆 𝑰𝒏𝒇𝒍𝒖𝒆𝒄 is quite a simple program. I do not need to go through this. It's just moving forward and moving out of the playing zone so that 𝑹𝒐𝒃𝒂𝒑𝒐𝒓𝒆 can come out from its hiding space. Okay, so now we go to the more in-depth on how I use right and left till black. We use proportional integral derivative control, which is for short called PID. It's actually used for a lot of purposes, like manufacturing purposes, where you do not want to overstress your motors and you would like to have a simple movement. Like if, for example, you were to do some mechatronics, you will find that some of the arms are moving quite smoothly. It's because they use PID control. So this is the formula where it technically just uses a few steps to calculating its error output and to its input, and using whatever value it is to convert it into a certain shorter value. So it's like example, if the value says 90 degrees, the motor will just turn 90 degrees, and that's it. So this is the formula. So to shrink it down, we use a proportion, which is also known as your gain. If you program the gain, where you change the gain depending on how smooth you want your movement to be, or how rough you want, so you can compensate and do more advanced stuff. So sensor value minus the imagery value, which is whatever value comes between what you want to do. For example, for my case, is white and black. So in between white and black, what is the value? So using those values, you get an error, which is usually found in the programming, where you might be seeing like, oh, I'm seeing black, so should I turn right because my sensor is seeing it, my right sensor is seeing it on the right, or should I go left to compensate and the other? So that is how the proportion comes in times, so that we convert that to something else. And that's it. And hope you guys have a nice day. And here's our performance.
Hi guys, I am Brian and I'm the group leader for our have order. This year is 𝑹𝒐𝒃𝒂𝒑𝒐𝒓𝒆 and this year is 𝑹𝒐𝒃𝒂𝒑𝒐𝒓𝒆.
Hello, my name is Justin. I'm the builder for team our have order. Beside me is Eve, and today our project is about a scene in 𝑹𝒐𝒃𝒂𝒑𝒐𝒓𝒆 movie.
1, 2, 3, start.